All right, today we are going to move our discussion of trigonometry away from just the right triangle trig and start talking about general angles and radian measure. So we have three learning goals today. First, we want to be able to draw given angles in degrees and radians in the coordinate plane. We need to be able to identify what are called coterminal angles. And we need to be able to convert angles from degrees to what's called radians and vice versa. So angles that are in standard position, two rays form an angle, and you should know that from geometry. When you drew all of your lovely little angles, you drew one ray this way, you drew one ray that way maybe, and you called the point that connected them the vertex. Now, when we're working in the coordinate plane, which is what we're going to be looking at here, you can generate any angle by fixing one ray, which we're going to call the initial side, and we fix that just along the positive side of the x-axis. So if this is the initial side, this ray, the positive part of the x-axis, is the first part. Then we can make an angle by rotating the other ray about the vertex, which will make the origin. So in the coordinate plane, we call an angle whose vertex is at the origin, initial side positive x-axis, as an angle in standard position. And the angles that we're going to be looking at are going to be ones in standard position. In other classes, you might look into ones that are not, but we're going to be focusing on standard positions. So if we have a angle that is positive, we are going to rotate in the counterclockwise position. So we said we were going to rotate the other ray, that's called the terminal side. So if I rotate counterclockwise, and let's say I go to here, if I rotate this direction counterclockwise, and here is my terminal side, then this would be a positive angle, because it meets all of the qualifications for standard position and positive. Angles that are negative, which I know that sounds weird, we've not talked about negative angles, but we are talking about general angles, and in the coordinate plane we have angles that are negative. Angles that are negative are simply ones that from standard position rotate the opposite direction, meaning that they rotate clockwise. So they have the same initial side right here and the same vertex at the origin, but they're rotating this direction. So my terminal side here for a negative angle, again, is made by the fact that I go counterclockwise. Now, certainly you can have negative angles that go down into this third quadrant. You can have positive angles that are in the third quadrant as well if you keep going past the 180 degrees. But that is just two examples of those types. So we're going to be able to draw angles based on those things. We also need to know what coterminal angles are, because this is going to be really important, because there are a lot of angles that we are going to study that are going to have the same trig values, and in many cases it's because they are coterminal. And coterminal just means that they're angles that are in standard position. So again, that means that we've got the initial side on the positive x-axis, vertex at the origin. So they're in standard position and whose terminal sides coincide. So a coterminal angle, you can see how in blue here I made this negative angle. I could make a coterminal angle that's positive. If I started here and went all the way around, the terminal sides coincide. So even though one angle is positive and one is negative, those are coterminal because their terminal sides line up on top of each other. So shouldn't be too hard to remember because co means together, and of course terminal for terminal side. So their terminal sides are together. A second new concept that we're going to be talking about is radians. And radians, sometimes people forget what they are because they think it's just a different mode on the calculator, which it is a different mode on the calculator. We made sure in our 13.1 lesson that our calculators were in degree mode. So what a radian is if we're looking at a circle, 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. So if we're looking at a circle here and this is the angle, we measure those angles in degrees. But radian measure also measures an angle, but what it's really talking about is this. So radians there are referring to the angle measure as a piece of the arc. So when we're talking about a full circle, most of you, if I ask you how many degrees are in a whole circle, hopefully you can shout it out to me, that there's 360 degrees in an entire circle. There are 2 pi full radians in a circle. So if I go all the way around the circle, 2 pi radians is the length around the edge, same as 360 degrees goes around the whole thing. So degree measure and radian measure are then related by the fact that 360 equals 2 pi. So if I wanted to simplify this equation, reduce it, then I could divide both sides by 2 if I'm solving for radians, and 180 degrees is the same as pi radians. So we use that to be able to convert back and forth. So if I have degrees and I want radians, take the degrees times pi over 180. If I have the radians and I want the degrees, I would multiply by the reciprocal, so 180 over pi. The key is that radians, notice here, has pi. So if you are being asked to convert something and you want an answer in degrees, you shouldn't have a pi left in your answer. If you do, then you've done something wrong. So the point, if you start with radians, radians are going to have a pi. Regardless of the value of r, they have a pi with them. So the pi's will cancel if you're going back into degrees. So if you want degrees, there shouldn't be a pi there because that is a radian measure. Okay, so that's a lot of explaining. Now let's look at what we're actually going to do with it. So example 1, we're going to draw an angle with the given measure in standard position. So when we're doing this, we are not measuring with a protractor. We are sketching, but you want your sketch to be accurate. So there is some level of accuracy that is expected here. So first it wants me to draw an angle in standard position with a measure of 400 degrees. Now, everything we measured in geometry only went up to 180 degrees because it went up to the line, because we were talking plane geometry. Well, now we're in the coordinate plane. We're going past that 180 degrees. So when I think about 400 degrees, I know 360 is a full circle. So when I draw angles, you always show what direction you're going and how far. So I actually, just like I did up here with the little arrows, you draw those when you sketch an angle in trig. So I'm going to start on my initial side and I'm going to start a loop. I know that 360 degrees is the full circle. So when I get here, I've done 360. I need 40 more degrees to get to 400. 45 degrees is half a quadrant. So that's what I mean by you need some level of accuracy. You should know that half of a quadrant is 45 degrees because an entire quadrant is 90. So I went a little less than halfway in order to come up with my angle sketch, and then you just need to draw the terminal side there. So this is what your sketch looks like. I've got my arrow showing the direction I went and how far, and then I've got my terminal side. So negative 120. So negative means I'm going to be moving in a clockwise direction. Negative 180 would be over here, half a circle rotation. Here, from here to here would be negative 90. So from negative 90, again, this is kind of an adding and subtracting game. 120 is 30 more than 90. So I'm going to go about a third of the way past my 90 to get to my negative 120, and then draw my terminal side. So there's negative 120 degrees. Now, make sure that when you work problems like this in the practice problems, that you have your numbers labeled with the degrees. If you didn't write it in the problem, then you would need to write it down here. Now, because we see it right here, you don't need to write it. But if you didn't, you can't just show me a sketch and I have no idea how many degrees it's supposed to be. So make sure you have the degree written with the problem or you label it down here. All right. Next one that we are given is in radians. So because they are new, you're not going to be very familiar with radians right off the bat. They take practice. And the thing that a lot of people hate about them is that they are fractions. So yes, we are going to have to continue to get better at fractions. And a lot of you have gotten a lot better as we've gone throughout the year. So if I look at this, 19 over 12, that's more than 1. Because 12 twelfths is 1. So I'm going to rewrite it as kind of a mixed fraction. So if I take out the 12 twelfths, 19 minus 12 is 7. So this is 1 7 twelfths pi. So remember that 1 pi is 180 degrees. 2 pi would be the full circle. So I haven't gotten to the full circle here. 1½ pi would be 1 6 twelfths. So this is just a tiny bit over 1½ pi. So that's the kind of reasoning that you need to go through when you sketch it, because again, you need to be somewhat accurate about its location. If it's a little more than 1½ and you draw it a little less than 1½, obviously it's not correct because it's not even in the right quadrant. So if I'm going to go 1 7 twelfths, so here is 1 pi, and again, it's a little more than 1½. So here's 1 6 twelfths, so just a little more than that, and then draw my terminal side. So there is my 19 pi over 12. All right, I'm going to have you try to sketch out D. I will give you a hint, -5 pi. That's more than a full rotation. So go ahead and sketch how you think that should look in pencil or out to the side if you're using pen. Just pause it real quick, this shouldn't take long, and then come back to see if you got it correct. All right, so -5 pi. I'm just going to count pi's as I go around, and because it's negative, remember that means I'm going to be moving clockwise. So here's -1 pi. -2 pi is the full circle, -3 pi, -4 pi, and then finally -5 pi. And it is exactly, I'll draw the terminal side right here, but it is exactly on top of that negative side of the x-axis. All right, example 2, find one positive and one negative angle coterminal with the given angle. So your answers might be different than someone else's because there are an infinite number of answers that you can come up with. But key is, again, one of them has to be positive, one of them has to be negative, and it has to be coterminal. So I like to sketch the original to kind of help me visually come up with something that's coterminal. So 55 degrees is a little more than halfway here. So here's my original. If I want a positive angle that is coterminal, all I need to do is go around another full circle. So I go the 55 and then I go another full circle around. So if I take 55 and I add a full circle, which is 360 degrees, that would give me a coterminal angle. So I can add those together, and that gives me 415 degrees. Can't read that very well, so I'll write it bigger. So there's one positive example. Again, you might come up with something different than mine, but that's the one that I chose there for positive. For negative, I just need to go the other direction. So if I want a negative coterminal angle here, instead of getting to that place counterclockwise, I'm now going to go clockwise. So when I'm going counterclockwise, notice that it's the full circle except for the 55. So in this case, I went 180 degrees and then almost all the way back around except for my 55. So it's only 55 degrees short of the full circle. So here, if I figure out what 360 take away 55 is, and then just make it negative, that would give me a negative coterminal angle. And again, I'm just going through my own reasoning process. There are lots of ways that you could come up with answers here. All right, B, 575 degrees. So first thing I would probably do here is I would take the 575 because that's obviously bigger than 360. So I would take 575 and I would subtract 360. So if I subtract 360 degrees, that's going to give me still another positive angle. So 215 degrees, I've already got a coterminal positive angle because all I did was take away a full circle. So 215 degrees, if half if half of the coordinate plane is 180, I know that 215 is 35 degrees more than 180. So go 180, go 35 more. Here is where that 215 would be, and again, the 575 was just a full circle more than that. So 215 is a positive coterminal. A negative coterminal, again, I just need to get to the same place except in the negative direction. So to get to that same place, remember that this was 35 degrees over the 180, and each quadrant is 90 degrees. So that means that this part was 55 degrees. So if you add all the little pieces together, the negative angle here, this quadrant is 90 plus the 55, gives me a total of 145 degrees for my negative angle. So there's my example. All right, 9 pi over 2. So here's my sketch. 9 pi over 2. 8 pi over 2 is 4 pi. So this is 4.5 pi. So we're working in radians now, but you can use the exact same type of logic. A full rotation is 2 pi. So if I've got positive 4.5 pi, if I take away 2 pi, that's still going to give me a positive 2.5 pi, and we always write our final answers in improper fraction with the pi. So 2.5 pi would be 5 pi over 2 is going to be a positive equivalent. So 2.5 pi. You could also make the equivalent, because if I do 2.5 pi, here is 2 pi, here's another half. You could also just subtract the 2 pi again, and pi over 2 would also be equivalent. So again, you can see why there are multiple answers. So 5 pi over 2 would be the positive coterminal. The negative coterminal, I've got to get to this exact, only this way. So going this way, this is 180 degrees, this is 270. If I count it in radians, here's pi, here's another half pi. So 1.5 pi is my negative. Again, we write them in improper form, so negative 3 pi over 2. All right, we're running kind of long here, so I'm just going to skip this guy for me, but if you would like to try it, that would be great, and you can check your answer with me tomorrow. That'd be a good way to see if you really understand how to do these radians, but I don't want this to go over too much here, so I'm going to kind of try to wrap this up. So rewrite each degree measure in radians and each radian measure in degrees. So here we're using our conversions. So if I start with degrees, that means I need to get a pi in there. So radians equals degrees times pi over 180. So degrees, I put it over 1, times pi over 180 degrees. So if I multiply straight across, that's 160 pi over 180. We always want it in simplest form. The zeros cancel. And these are both divisible by 2, so 8 pi over 9. And that is my radian equivalent. This one I started with radians. I want degrees, so I'm going to go the opposite. Instead of pi over 180, I'm going to do 180 over pi. And again, I want the pi's to cancel. So multiply straight across, pi's cancel, 180 over 10. So that just cancels the 0. So that is 18 degrees. And think about whether your answer makes sense or not. Look at how many degrees this is. 160 is close to 180, so it's close to 1 pi. This is close to 1 pi. Pi over 10 is very small. 18 degrees is very small. So you just want to make sure that it makes sense. All right, I would like for you to quickly do these last two, C and D, and pause it real quick and then check it. All right, so this one starts with degrees, so that means I'm going to multiply by pi over 180. So negative 250 pi over 180. The zeros cancel, and 25 and 18 do not have any common factors, so there's nothing we can do to reduce those. So negative 25 pi over 18 is going to be our final answer there. On this one, we have radians, we want degrees, so we need pi to be on the bottom so that they cancel. So cancel the pi's. Here, I would actually cross reduce here before I multiply, because that just gives you smaller numbers to work with. I know that 6 goes into 18 3 times, so 6 goes into 180 30 times. That just makes it that much quicker. So now, negative 5 times 30 is negative 150. 1 times 1 is 1, so that's it, negative 150 degrees. And that's the way the cookie crumbles.